Okay, welcome to another Orbiter Spaceflight Simulator video. And in this video, I'm going to be taking the XR2 from, looks like I'm at Wide Awake International. To be honest, I didn't even know where I was at. So I'm going to be taking the XR2 from Wide Awake International up to orbit so that I can dock with a vessel that's in orbit called the ICV. And I can't actually remember what ICV stands for. I think it's Interplanetary Something Vehicle. Now, this is a really nice add-on that was made by Video Space Effects. I've had it for quite a while. I've just never gotten around yet to recording a video with it. Now, this scenario does come with the add-on, and if I recall correctly, the scenario is that you're going to dock with the ICV, which is in orbit, and it's set up, I believe, on a date that allows you to then transfer to Jupiter. Now, I actually don't have the time to record a flight to Jupiter, so my scenario is that this is going to be a dry run for the people that are aboard the XR2, so they're basically doing a proof of concept flight to try out the brand new ICV to make sure that they can take off and rendezvous with it, and then everything will be okay. And at some point in the future, the crew will then do a real flight where they're going to take off, dock with it, and then go to Jupiter. So that's the plan. Let's go ahead and switch camera views and jump into the flight. Control F3 back to the XR2, and the reason I said I didn't know where the XR2 was at was because I haven't actually loaded the scenario and taken a good look at it, so therefore I didn't actually realize it was at Wide Awake, but I can see up there, that's where we're at. Inside the vessel, and we're going to bring up this view here. And let me just kind of dig in here, so let me target the ICV, that seems to make sense. And then I'm going to change the display lines to orbit plane. And I can see here that the orbital plane of the ICV it's not passing over our site quite yet. I'm not actually sure how much that matters for this particular flight, but we'll go ahead and kind of do the standard concept here for taking off, getting into orbit, and with the intention being that you're going to be in plane with the target vessel by the time you already do that. Now, I've got a whole series of videos in the Absolute Beginner Guide that kind of explains the way you need to think in order to do that, so I'm not going to cover that so much here. But I will bring up a line plane on this side. I'm going to target the ICV as well. And according to this MFD, I can see that we're going to be approaching the ascending node. So that means that when we take off, we're going to be wanting to, looks like we'll be wanting to go more of a south type of direction of flight. We can also use launch MFD. It's not really necessary, but it has some things about it that can make this type of thing a bit nicer. So I'm going to do target ICV-1.
Target selected.
And again, since I'm just going to be doing a rendezvous, I don't need to worry about setting up transx or IMFD or any of that to do the whole interplanetary mission, because I don't plan on doing that. But according to Launch MFD, it says that when we do take off, we're going to want a heading of about 113 degrees. So again, that's slightly south of 90. And the time to the intersection, so the time that this yellow line will be basically passing straight overhead, is 17,830 seconds. So it's what is that, about a quarter of a day, something like that. So first order of business is going to be to warp time forward to get closer to that point. Now, we want to lead our time of takeoff, usually in these types of vessels, by about 315 seconds. And somebody recently asked me why you want to do that. And the best explanation that I could really come up with was to sort of say that you basically just need to get a running start. Because you have to remember that sitting here on the runway, we're basically at a dead stop. Now, we're not completely at a dead stop because technically there is the rotation of the Earth, which adds to our velocity, and we'll take advantage of that, but more or less we're at a dead stop. So if you could imagine, pulling up onto a highway and coming to a complete dead stop on the ramp, and then needing to merge into the traffic that's going down the road at 70 miles an hour, well, that's kind of difficult to do if there's a lot of traffic. But if you pull up onto that ramp and you've got about, 30, 40 miles per hour already working in your favor, then it's much easier to merge into that traffic. So that's kind of why we take off, 300 seconds in advance, 315 seconds in advance. That way we can get some momentum, some forward speed. Now, that number is not completely arbitrary, that 315 seconds. It's basically how long does it take your craft to reach orbital velocity, and then divide that by 2. So it takes the XR2, it takes the space shuttle, it takes the standard Delta glider, roughly 8-9 minutes, somewhere in that range to reach orbital velocity. So we take that number and divide it in half. That's how we come up with about 315 seconds. Okay, so again, warping time forward, 10, 100. You can kind of watch how that orbital plane progresses westward. We can go a little faster than that. And be a little careful with your time warp. Unless you're out in space going between planets, anything over 1,000 gets kind of funny. And our number just reset, so let me check align plane, see exactly what happened there. Zoom in on my location. You can see it hasn't reached us yet, so I'm not actually sure what happened just now. That was weird. Let me check launch MFD again. I don't think I've ever seen that before, but it flipped. It went from, like 3,000 or whatever it was all the way out to 88,000. I've never actually seen that before, so I'm just not going to use launch MFD. I'm going to use align plane instead. But we know that our takeoff direction, our azimuth, is going to be about that 113. And I also have a video where I've kind of explained how you can calculate that, or at least some tools that you can use to know what launch heading you want, because since we're not at KSC and we're not going to the ISS, we're not going to use, that 43 degree heading. We're going to use some other heading, and we need to know what that heading is going to be. And again, the easiest way to do that is launch MFD does give you the accurate number, 113. I just don't know why the time to intersection suddenly decided to reset. It's odd. But anyway, 113, that's what we'll go with. So let's go warp time forward to get closer to that point. So we're getting there. And when the time to the node is about 3:15, I'm going to hit the gas. Okay, we're getting really close to that point, so let's switch over to this view and get everything ready to go. Turn on the APU. And once the APU is up and running, you can turn on surface controls. Make sure that the RCS mode's off. We don't really want to be fighting translation thrusters and such. Make sure external cooling's off. One of the things I should have did before I started time warping was to make sure that it was on in the first place. But the scenario comes with it turned on, but I didn't know that for sure. So before I time warped, I should have checked that, because if I had time warped forward by 15,000 seconds, it would have brought my coolant temperature way up. Alright, so we are getting really close to that time to go. We're about 3:45 right now. I don't need to have this view open for any reason, so I'm going to go ahead and switch over to the larger view so that we can see these MFDs a little bit better. And yeah, we'll do a scram ascent, so I need to keep that in mind too. Go forward here, and we'll take off here in just a couple seconds. Let's get going. And it doesn't have to be exactly 3:15, whatever. All right, we're ready to go.
100 knots.
Get my finger on the landing gear. Get ready to lift. I heard V1, but not rotate. That happens sometimes.
Wheels up.
Wheels up, get to 10, 20 meters off the ground, bring up the landing gear.
Gear deployed.
Start banking a bit
Warning.
here.
Gear deployed.
Really close to the heading that we need, so we don't have to do too much of a bank maneuver there. Full throttle on the main. Pitch up, and while I pitch up, I'm going to start banking just a touch, because I noticed I'm a little bit off. It was 113.5 is what it said was ideal, so we'll go with that. And we can pitch up pretty aggressively here at the beginning of the flight. Just watch that we don't overdo it, because we'll get wing stress warnings, make the pilots and passengers very sick. So there we're just past 113. Now I just want to keep an eye on the time to the node, make sure that's constantly counting down. And if you look over here at map, let me actually make sure I'm tracking my location, then you'll notice that as we get closer to the correct alignment, then the green line will swing around more in line with the yellow line. Let me Alt-H to a better color. Probably go green now, yeah, that's fine. Looks like I need a bit more of a bank. We're slipping slightly to the northeast. But again, I want to watch that time to the node, make sure it's counting down. 15 kilometers, I did say we were going to do a scram ascent, so it's time to start leveling off. Actually, I should have done the leveling off sooner, because now I'm having to put in a lot of aggressive down pitch, which I'm sure is causing pretty high loads, G loads.
Information. APU fuel 90%.
We're almost down to straight and level flight. Time to the node still counting down.
Mach 3.
It's Mach 3. I'm going to have to switch over to this view because I don't have the keystrokes memorized anymore. I'm going to open the scram doors. And control equal sign brings up the scram. While I simultaneously killed the thrust, but we really got to watch our heat at this point, because we will heat up the vessel, and that'll be the end of the mission if we're not careful.
Mach 5.
Time to the node still counting down. Okay, we're heating up pretty significantly, so I want to watch that. Put in some more up pitch.
Warning, hull temperature.
Watch that. Getting pretty hot. Pretty hot.
Warning, hull temperature.
Okay, but when you do your up pitch, you want to make sure that you don't overdo it. Don't get scared and suddenly, pull up so much that you have a vertical speed of, 700, 800 meters per second or a kilometer per second, because then you end up climbing way too high, way too fast, and then your scram engines aren't doing you any good. So notice I just tried to keep it just ahead of the point so that it wouldn't overheat, but not too much.
Mach 10.
Time to the node still counting down. No, it's actually counting up. So I'm actually going to pitch the other way for a couple of minutes.
Mach 11.
Bank, I should say. Bank the other way.
Mach 12.
Watch the temperature, watch the vertical speed. Notice the vertical speed's getting pretty close to 0, which means we're going to heat up quickly if we're not careful. And if you're thinking, what are you doing right now? Your rate on your align plane is all out of whack. It's increasing, it's not decreasing, which means your relative inclination is getting worse, not better. I'm aware of that, but I need to get to a point where the time to the node is counting down. Otherwise, I have no hope of getting a perfect 0.00 inclination. So it has to get worse before it gets better.
Mach 15.
Unfortunately, I'm getting closer and closer to orbital velocity, so I may not be able to get a good relative inclination on this flight. Okay, we're at time to the node's 90 seconds. I'm going to try to go the other way now to bring the inclination down.
Mach 17.
Temperature's good. Now the time to the node's counting down, and the relative inclination is slightly getting better, and I can probably afford to put in a little more input this way.
Mach 19. Mach
Warning,
20.
scram temperature.
Close the scram doors.
Warning, scram temperature.
Back to full power on the main to complete the ride to orbit. And that wasn't the greatest
Mach
ascent,
21.
obviously, because we still have a pretty good amount of scram fuel. That's 20%. That means I kind of botched the ascent.
Mach
Time to the node is
22.
20 seconds, and we still have a degree, so I can now put in quite a bit of bank here.
Mach 23.
Alright, now I'm going to bring up orbit MFD. Switch to this view here.
Mach 24.
Change the projection, the distance. Oops, distance. Start throttling back. You know, one thing I didn't check was what the altitude was of the not the
Mach
HCLV, the
25.
ICV. That's what that thing's called. Alright, so we're going to go with that, and I'm going to try to kind of work with the relative inclination just a little bit here more, while I still have a little bit of the atmosphere left working in my favor. In fact, what I can do...
Rotation
Pitch.
off.
go very much on the side, pull back, and you'll notice that the relative inclination will come down quite a bit more, or at least the rate will get better.
Mach 26.
Here for just the last couple of seconds. Surf the atmosphere to help us improve things. And you don't want to overdo your bank angle, I should say pitch. The maximum pitch you want is an AOA here of 15 degrees. If it goes any higher than that, then you're actually, you have less efficiency on your pitch. And you notice the relative inclination is now down to 0.06, and we might get it down a little bit lower than that even, but it's not going to be perfect because you can see the this swinging around. Once it hits dead center, that's as good as it's going to get, but a 0.04 relative inclination is not bad at all, if I do say so myself. It's not perfect, it's not 0.00, but it's pretty good. Being that that's as good as it's going to get, we can now roll back over to a heads-up position. We're getting close to 100 kilometers, which means I can turn the APU back on and open the radiator before I forget to do it, which I have a tendency to do. Okay, radiator open. In fact, I think I want to bank just a touch this way. Yeah. Okay. Alright, so the radiator is extended. Turn the APU off because I think I might be in a...
Mach
I don't know if this is an
26.
expert configuration or not. I didn't check how Video Space Effects set up this particular scenario. Go ahead and switch over to the orbit HUD. And we're coming up close to 20 minutes on this part of the flight, so let me go ahead and pause it. Control P. And we'll just go ahead and end it here for now. And when we come back, I will go about what I need to do to begin the process of rendezvousing with the ICV. So if you like this part of the video, please hit the like button down below, and if you didn't like it, that's fine. Thumbs down. If you're not already subscribed to the channel and you're interested in all this spacey stuff that I do here, please do subscribe so you can be notified when I upload new videos, and I will see you in the next part. ICV, and I can't actually remember what ICV stands for. I think it's Interplanetary something vehicle. Now this is a really nice add-on that was made by Video Space Effects. I've had it for quite a while. I've just never gotten around yet to recording a video with it. Now this scenario does come with the add-on, and if I recall correctly, the scenario... Okay, welcome to another Orbiter Spaceflight Simulator video. And in this video, I'm going to be taking the XR2 from, looks like I'm at Wide Awake International. To be honest, I didn't even know where I was at. So I'm going to be taking the XR2 from Wide Awake International up to orbit so that I can dock with a vessel that's in orbit called the Control F3 back to the XR2. And the reason I said I didn't know where the XR2 was at was because I haven't actually loaded the scenario and taken a good look at it. So therefore I didn't actually realize it was at Wide Awake, but I can see up there, that's where we're at. Inside the vessel, and we're going to bring up this view here. And let me just scenario is that you're going to dock with the ICV, which is in orbit, and it's set up, I believe, on a date that allows you to then transfer to Jupiter. Now, I actually don't have the time to record a flight to Jupiter, so my scenario is that this is going to be a dry run for the people that are aboard the XR2, so they're basically doing a proof of concept flight to try out the brand new ICV to make sure that they can take off and rendezvous with it, and then everything will be okay. And at some point in the future, the crew will then do a real flight where they're going to take off, dock with it, and then go to Jupiter. So that's the plan. Let's go ahead and switch camera views and jump into the flight.